So just how hot can we get something by heating it with a Bunsen burner? That's what we're going to do today in our lab on the temperature of a lab burner working with calorimetry. So let's get started. So just how hot can we get something by heating it with a Bunsen burner? That's what we're going to do today in our lab on the temperature of a lab burner working with calorimetry. So let's get started. So what we're going to be doing is taking the mass of this iron bolt. Then we're going to be heating it with the Bunsen burner, and when it reaches the maximum temperature, we're going to plunge it into a certain amount of known water, a certain mass of water, and we're going to look at the temperature change of that water. With that information, we should be able to figure out what was the initial temperature of this bolt. So to figure that out, one of the first things we're going to have to do is figure out what is the mass of this bolt. So our first data point is our mass of the iron bolt is 35.958 grams. So our next step is to obtain some water, and to read the volume of this water, again, I hold the graduated cylinder up to eye level and I read the very bottom of the meniscus to determine that I actually have 242 milliliters of water. Another data point, 242 milliliters of water. By the way, water has a density of 1 gram per milliliter. So if I have 242 milliliters of water, how many grams of water do I have? So now I'm going to place the 242 grams of water into a styrofoam cup. It's good because it's insulated. It's not going to allow a lot of heat to escape to the surroundings. Could be better, but it'll work for this. Alright, so the next step of this procedure will be to determine the temperature of this water. This thermometer is actually graduated to single units, so I can estimate out to the tenths for my sig fig rules. The temperature of this water is 22.1 degrees Celsius. Alright, so now the fun starts. I'm going to take my iron bolt, attach it to a little wire, a little nichrome wire. Nichrome has an extremely high melting point, so I'm not going to worry about it melting, and I'm going to tie that up on my ring stand, and we're going to go ahead and start heating our bolt. Of course, what am I doing? Ah, yeah, need the glasses. So let's go ahead and get this cooking. So again, I want just the tip of that inner blue cone touching the tip of that iron. And we're just going to let this cook for a while and see what happens. So as you can see, it's starting to warm up a little bit. We've got this beautiful sort of space shuttle re-entry look going on. And the nichrome wire glowing red hot. I don't see our bolt quite red hot yet, so I'm going to let it keep going. Alright, now we're looking pretty good. I can see the bolt is glowing red. Don't know if I can get it any hotter than that. So in a coordinated effort, what I'm going to do now is I'm going to shut the burner off, slide it aside, and immediately plunge the water plunge the water around the bolt. And obviously the heat is going to go from the bolt into the water, bringing the temperature of the water up and the temperature of the bolt going down. Bring the temperature of the bolt down. There we go. So obviously at the end of this, both the bolt and the water will have the same temperature. So let's give this a shot, shall we? Oh, lots of bubbling. I've got steam. You can see that. Splattered a little bit. Carefully mixing this so I do not allow the tip of this thermometer to touch that water. And of course the temperature is going up. Kind of want to mix this around so that the hot water doesn't sit on the top with the cool water. Looking for a nice uniform temperature here. And as I look at my thermometer, it looks to be at 38.7 degrees. With this data, I can determine how much heat went into that water. I know the mass of the water, I can determine the change in temperature of that water, and the specific heat of water is given as 4.18 joules per every gram Celsius. I know how much heat went into that water. Where did that heat come from? It obviously came from the bolt. So I can determine the temperature change of that bolt, knowing the amount of heat the bolt lost. Hey, that's the same as the amount the water gained. I know the mass of the bolt. I also know the specific heat of the bolt is given as 0.450 joules per gram Celsius. I can find the change in temperature of the bolt. And if I know the change in temperature, how much it fell, and I know its final temperature, the 38.7 degrees, I can figure out its initial temperature. By the way, a change is always the final minus the initial, but obviously the change in the bolt's temperature was a negative quantity. So good luck with this, and I will see you when I see you. Thank you.